of output. Laplace transform, you already know that.
Yes.
So what is your basically stream? Which stream? You are medicine, huh?
Biomedical engineering.
Oh, okay. Laplace transform of output.
Okay.
So suppose a circuit, for example, I am considering a time domain circuit. The time domain circuit, which is a electrical circuit, I am considering, for example, electrical circuit I considered. All the parameters are in time domain. Resistance, inductance, capacitance, or voltages, currents, all are in time domain. So Laplace transform is a technique which converts from time domain to S domain. So the Laplace transform of output, which will be in C of S. Suppose, for example, I am naming as Laplace transform of output is C. So you have to write Laplace transform of output in C of S.
Self Laplace.
S is nothing but Laplace. S domain. Output I represented is C, capital C.
Okay.
And Laplace transform of input. This is the definition of transfer function. I just written output as OP, input as IP. So Laplace transform of input. So input is represented in control system R. Since it is an Laplace transform, R of S. So transfer function, the definition of transfer function in control system, the Laplace transform.
CFS by RFS.
Come again?
It will be CFS by RFS.
Yeah, CFS by RFS. The Laplace transform of output by Laplace transform of input, CFS by RFS. So here one condition is there, assuming zero initial conditions.
Okay.
Assume every time we are not writing this one, assume, but we have to assume zero initial conditions. Initial conditions are zero.
Okay.
So that is the disadvantage actually. So since why it is disadvantage, in all the cases we can't take the initial conditions as zero. In some cases, some applications we can take the initial conditions as zero, but we can't able to take in all the cases. So that is this disadvantage is overcome by state space analysis. Anyway, this topic is only signal flow graph. Just I am telling.
Okay. Okay.
So here this is the definition of transfer function. The Laplace transform of output, which is represented as C of S, and divided by Laplace transform of input, which is represented as R of S. So assuming initial conditions are zero. So this is the definition. So I already told this, there are various techniques to find out the transfer function in control system.
Okay.
So there is one more technique, block diagram reduction process is there. So we have to follow some rules. So since this demo class I am taking only signal flow graph. So signal flow graph I will explain. So when I am going to take classes, then I will explain all the techniques, whatever the syllabus you have.
Okay, sir.
So one technique is, there are two techniques mainly to find out the transfer function. One is block diagram reduction process and signal flow graph. So these two techniques, I just seen your syllabus also. These two techniques are there in your one unit, particular unit, I think.
Okay.
Unit number 2.
Unit 2.
Block diagram, armature and field control motors. Various block diagrams, various techniques, block diagram reduction, Mason's gain formula and its application to block diagram reductions and signal flow graph. This is unit 2. Okay. So under unit 2 I am taking signal flow graph topic now.
Okay.
So signal flow graph, there are two techniques, block diagram reduction process and alternative method is signal flow graphs. So the disadvantage of block diagram technique is we have to follow some rules. So by applying the rules, we will get the final transfer function for a system, for a control system. Okay. So by applying some rules, we will get the transfer function, final transfer function. So that process, it takes time to get the final transfer function. To calculate the transfer function, overall transfer function for the system, it is time taking. This is one disadvantage, main disadvantage of block diagram reduction process. One more disadvantage is it is tedious. It is very difficult. Okay. Some complex control system, if you take, it is difficult to reduce, it is difficult to reduce also. Sometimes we feel. So in order to work on these disadvantages, signal flow graph. Signal flow graph is alternative method. So which is developed by S.J. Mason. The scientist name is S.J. Mason. He invented the signal flow graph technique. So based on the name also, the formula name also, they put on his name only. His name is S.J. Mason. The formula name also Mason's gain formula. He is scientist. The formula is Mason's gain formula. You can also write in the whiteboard.
Oh, okay.
Yeah, if you want to write means you can write also. So just by using just one formula, we can find out the overall transfer function for a control system, whether it is complex control system or easy control system, anyone. So just by using one formula, no need to apply here rules also. There are plenty of rules are there to find out the transfer function by using block diagram reduction process. So we are not applying any formula, any rules here, just one formula. So what is that formula? So before going to that, I'll just write formula, and so Mason's gain formula, so which is represented as TF. TF is nothing but transfer function. In some textbooks they will put T. It is different. It is based on textbook to textbook. The representation is okay. I am writing as transfer function as just TF, transfer function. So this is the formula: 1 by delta. Some textbooks they call transfer function as system gain also. Both are same. System gain, transfer function, all are same names. So 1 by delta sigma k sigma is summation where k is a constant. So this is the Mason's gain formula to find out the transfer function for the overall system. So this
delta.
Yeah, delta. I will tell you. So 1 by delta sigma k is a constant, pk and delta k. So this formula, this Mason's gain formula, which is relationship between input variable and an output variable of a signal flow graph. See, transfer function is, what is transfer function? C of s by R of s, right? Just now I told C of s by R of s. C is nothing but output and capital R of s is nothing but input. So this transfer function, this formula also, which is relationship between input variable and output variable. Output variable is C and input variable is R of a signal flow graph, which is given by the net gain between the input or output nodes and is known as the overall gain of the system. Overall gain is represented as TF. So this is the definition. Signal flow graph, Mason's gain formula is based on the relationship between input and output variable of a signal flow graph is given by the net gain between the input and output nodes and is known as the overall gain of the system. So before going to the further about this formula, okay, just I will explain the formula now. So where P suffix k represents path gain, P suffix k represents path gain of the kth forward path. P suffix k, which is represented as path gain of the kth forward path, and TF is nothing but overall gain of the system or transfer function. So how to find out delta? Delta is nothing but determinant of the signal flow graph. So just first I am explaining the formula terms. After that, then I'll explain what is signal flow graph and what is node and all. So what is delta? So delta is nothing but determinant of the signal flow graph. Determinant of the signal flow graph. How to find out? how to find out one formula is there. Based on one formula we can find out this signal flow graph, which can be calculated. So determinant of the signal flow graph, 1 minus sum of loop gains. I'll explain what is loop gains and all. 1 second, I will write.
Okay.
One minus sum of loop gains of all individual loops.
Okay.
Bracket over plus sum of gain products of all possible combinations of two non-touching loop. I'll explain what is loop, what is non-touching loop and all. Then minus sum of, so the polarity is alternatively plus 1 minus again
Okay.
plus minus, like that. Sum of
Okay.
gain products
Three non-touching, right?
yeah, possible combinations of so this is the formula we can calculate by using this. So 1 minus sum of loop gains of all individual loops plus sum of gain products of all possible combinations of two non-touching loops. So minus, like that it continues, so on.
Okay.
So what is individual loop, non-touching loop? I will explain. Just the definition. This is the determinant, how to calculate the determinant. Next, delta
Okay.
k. In the problems we will see how to calculate and all. So delta k is equals to, so delta k is nothing but value of delta. Both are same, but
Okay.
delta k is also definition of delta only, value of delta, but for the part of the graph,
The case part.
for the part of the graph which is not touching, so which are the kth forward path, the kth path should not touch. For the part of the graph not touching the kth forward path. Forward path, just I written FWT. So this is how to calculate delta k. So we'll see how to do these problems. I'll explain in the problems. K is like k p pk suffix k is the path gain of the forward path, kth forward path. Delta, determinant of the signal flow graph. So alternatively plus and minus. So plus 1 minus sum of loop gains of our individual loops plus sum of gain products of all possible combinations of two non-touching loops minus sum of gain products of all possible combination of three non-touching loops. Next plus, so like that, so on. Next 4 non-touching loops. Next minus 5 non-touching loops, like that. So this is the formula, Mason's gain formula. By using this we are finding the transfer function. So before going problems, so I will explain what are some terms. So what is node, what is loop, So how to draw the signal flow graph? So a signal flow graph, the definition of signal flow graph, which is a graphical representation of the relationship between the variables of set of linear algebraic equations. So which signal flow graph is a network. Signal flow graph is a network which consisting of mainly, first one is node. So what is node? Nodes are which is represented as system variables. Nodes represented as system variables. Node is nothing but system variables which are connected by direct branches. So for example, I am considering the one closed loop system. So closed loop system, and what is open loop system? Open loop system is there is no feedback. Closed loop system, there is a feedback. So I am taking the closed loop system. So one example I am taking closed loop system and how to draw signal flow graph for this. So this is known as summing point. This cross symbol is known as summing point. So input is represented as R of S. So here plus and feedback is negative. The feedback signal which is represented as B of S. So the error signal between input and feedback signal which is represented as E of S. So E of S is equals to, what is E of S? So summing point is nothing but it sums all the incoming signals. So R of S minus B of S. Since R of S is plus is given and B of S is given minus, so error signal between input and feedback signal is R of S minus B of S. So this is the forward path transfer function. G of S is nothing but which is represented as G of S, forward path transfer function, and the output signal which is represented as C of S. A simple closed loop system which have one forward block and one feedback block. G of S is the forward block and feedback block is H of S. So the cross symbol is summing point and this symbol is, this point is nothing but takeoff point. From the output I am taking signal and again I am fed back to the input. So this is known as takeoff point and this cross symbol is known as summing point. You see,
So what is the function of the forward block?
forward block, this is a forward transfer function. Function and all we will explain in application.
Okay.
This I am not considering any application. Just one simple closed loop system I consider. Functions and all based on the application we will explain. When I come to the applications, closed loop system, open loop system, that time I will explain. So this is R of S which is represented as input signal, C of S output signal, B of S feedback signal, G of S represents forward path transfer function, H of S represents feedback path transfer function, E of S represents error signal. So this is negative closed loop. The negative loop, here feedback loop is negative signal, that's why it is negative closed loop system. So for this closed loop system, how to draw signal flow graph? Signal flow graph, just I am writing as SFG. SFG represents signal flow graph. So input is R, right? Input is R. And here the summing point which is I am represented as node. From the summing point, here E is there. E, this is also one node. From summing point, from input to node E, the gain is 1 I am writing. And here feedback signal B, but here minus is given, right? In the block diagram minus is given, so minus 1. And here the B is represents node, and feedback transfer function is H of S. This I am just writing, this is gain, H I am writing. And forward path transfer function is G of S. This is forward path gain, G. Gain is nothing but output by input. And output node is C. From the output node again, here 1 I put, just see, both are same. This is so here how many nodes are there? R is the input node. Here R is the input node. Capital R is the input node. C is the output node, and E is the error signal, and B is also node. But G and H are not nodes. G and H are gains. So node, what is the definition of node? Node is nothing but system variable. So here nodes are R,
E, B,
and C. So R, E, B and C, where R and C are the input and output node. R is the input node and C is the output node. So our node is nothing but it represents a system variable which is equal to the sum of all incoming signals at the node. Outgoing signals from the node do not affect the value of the node variable.
okay.
So what is branch? So next definition is branch. A signal travels along a branch from one node to another in the direction indicated by the branch arrow, and in the process gets multiplied by the gain of the branch. So here what are the nodes? Here R, E, B, C are the nodes. So signal is traveling. So signal is traveling with the gain. 1 is gain from input node to another node, which is E is another node. Input node is E, R, and another node is E. So what is the signal gain? 1 is the signal gain, which is branch arrow. This is the arrow indicates nothing but branch arrow. The branch is nothing but RE. Okay, so branch is nothing but RE. So like that. Similarly, C is the, for this branch, C is the output node and E is the input node for this branch. For this branch gain is G. For this branch gain is G, which is indicated by branch arrow. For this branch, C is the output node and E is the input node. The node variable C, we can write it as in terms of branch gain. Branch gain, what is branch gain here? G.
G.
So C is equals to G into E, where G is the branch gain. Okay, you can write branch gain or branch transmittance. Both are same.
Okay.
So for example, I am considering one node. So this is the node. So this node has a summing point and takeoff point. I will explain how this node has summing point and takeoff point. So this is the node. And these are the inputs. X2, X3, X4. All these are nodes. X2, X3, X4 are input nodes, and X1 has intermediate node, and X6, X5 has output node. So how we are saying input and output node? By just arrow. Here the arrow is given. So the this branch gain is A21, and this branch gain is A31. A A41. See suffix 31, 21, 31, 41. That means 2 is the input node and here 1 suffix represents output node for this branch. And
Okay.
this branch is A16,
A16.
A15.
A16.
So A represents all gains. A21, A31, A41, A16, A15 are all branch gains. So X2, X3, X4, X1, X5, X6 are all nodes. So here I am considering X1 node, this X1 node as a summing point, as a transmitting point also. So how this summing point? First summing point I am writing X1 is equals to, I can write A21 X2 plus A31 X3 plus A41 X4. So this is the summing point. X1 is the summing point which sums all the incoming signals. Incoming signals are A41, A31, A21. So this node, X1 node, has a summing point as well as transmitting point. So this is how it is summing point, and same X1 as transmitting point. How? So X5 is equals to A15 X1, and similarly X6 is equals to A16 X1. So the node X1 has same both summing point as well as the transmitting point. So here input nodes are X2, X3, X4, and output nodes are X5, X6. So what is the input node? It is a node with only outgoing branches. So if you take X2, X3, X4, there are no incoming branches. Incoming signals are not there, only outgoing signals. So whichever the node have only outgoing signals, that nodes are incoming input nodes.
Okay.
Output node, it is a node with only incoming branches, incoming signals. So here X5 and X6, if you observe X5, X6, which have only incoming signals, there are no outgoing signals.
Okay.
But X1, if you see, which have incoming signals as well as outgoing signals, that's why it is known as intermediate node, which have incoming signals and outgoing signals. It is an intermediate node. So what is path? Next definition is path. It is a traversal of connected branches in the direction of the branch arrows such that no node is traversed more than once. So in this figure, tell me how many paths are there. I'm repeating the definition of path. It is the traversal of connected branches in the direction of the branch arrows such that no node is traversed more than once.
Three paths are there.
What are the paths? Tell me.
R and E.
Okay.
And E and C.
Okay.
Then C and B and E.
Yeah, those are all nothing but branches, not path. So path is nothing but R and E is branch, E and C is branch, C and B is branch, B and E are branches. It is a traversal of connected branches. RE is one branch and EC is one branch. So connected branches, these are all connected, right? So with the direction of branch arrows is represented here. So it is the traversal of connected branches in the direction of the branch arrows such that no node is traversed more than once. So I am starting from R, the path. I am started from R. Here I will take one more color. I started here. So this is one path. It is a traversal of connected branches. What are the connected branches? RE one branch and EC in the direction of the branch arrows such that no node is traversed more than once. Here the what are the nodes? R, E, C. These nodes are touching only one time, not more than one time. If it is touching more than one time means that path is not a path. If it is touching more than one time means that is nothing but loop. It is the traversal of connected branches in the direction of the branch arrows such that no node is traversed more than once. So this is also nothing but forward path. So what I drawn with rose color, rose or what forward path. It is a path from input node to output node. Forward path is nothing but input node to output node. How many paths here? Input node to output node, only one path. Input node is R and output node is C. So forward path is a path from input node to output node.
Okay.
And loop, what is loop? The definition of loop, it is a path which originates and terminates at the same node. So in this signal flow graph, how many loops are there?
One loop.
Yeah, only one loop. So if we consider this one, so it is a path which originates. I am starting from at E. It is a path. The connection path is nothing but it is a traversal of connected branches in the direction of branch arrows. E and C one branch, and C, B, B, E, three branches are there. It is a connected branch arrows also is shown. This is the path. Originates and terminates at the same node. E is the starting node and terminating node. So this is the loop. Loop gain is nothing but, so loop path is the E, C, B, E. This is the loop. See here, E and E, starting and ending, same letter, same node. And loop gain is, what is the gain? For this EC, the gain is G. For CB, the gain is H. And BE, the gain is minus. So the loop gain is minus GH.
Okay.
So loop gain is nothing but it is a product of branch gains encountered in traversing the loop. So in this loop, whatever the gains is coming, just multiply G into H into minus 1 minus GH. Forward path gain. So this is the forward path, right? Forward path is the node between, forward path is a path between input node to output node. So what is the gain? 1 into G into 1. So this is the forward path gain. And this is the loop gain minus GH. Okay, understood definitions?
Yeah.
So I will give some equations. So from equations, first we have to construct the signal flow graph. How to do that?
Okay.
So first one algebraic set of equations I will give. So from the equations, how to construct the signal flow graph. So next. So x2 is equals to a12 x1 plus a32 x3 plus a42 x4 so this is one equation. Next, second equation, x3 is equals to a23 x2. Next equation, x4 is equals to So next equation, x5 is equals to a35 x3. So these are the equations given. So from equations, first construct the signal flow graph. The first step is constructing a signal flow graph. Next we will find out how to find out the gain also. Overall gain, that is nothing but transfer function. So x2 is equals to, so from this what is given is x1 as input variable and x5 as output variable. X1 is input variable, x5 as output variable. So that is given. So first how to construct the signal flow graph. So from the given data, so first identify the nodes. What are the nodes? x1, x2, x3, x5 are the nodes, right? A12 these are all gain. A12, A32, A42 these are all gains. So x1, x2, x3, x4, x5 are the nodes. From these nodes, x1 is the input node and x5 is the output node. That information we know that. So just locate the nodes. Just locate the nodes. So this is x1. x2. x3. x4 and x5. So I just located the nodes x1, x2, x3, x4, x5. So come to the first equation, x2 is equals to a1 to x1. So that means from x1 node the gain is coming a12. Next one, a3 to x3. So from x3 node the gain a32 is coming. I am just drawing like this. From x4 a42 is coming. From x5 a52. So this is the first equation. X2 is the summing node. So it sums from the signals x1, x4, x3, x5. So first equation is over. So come to the second equation. So x3 is equals to a23 x2. x3 is equals to a23 x2. So second equation is over. Come to the third equation, x4 is equals to a34 x3. From x3 the gain is a34. And if you see this equation, a44 x4 is there. x4 is equals to a44 x4. That means, so like this. A44 x4. Same node. So now come to the last equation. x5. x5 is equals to a35 x3. So from A35. A35 and from X4 the gain is A45 and just by keeping as 1 and X5 same. For our clarity purpose I am writing like this. So this is the signal flow graph. So they given following set of equations having a system which is described by set of equations is given. So from equations I just construct the signal flow graph. So now we will see how to find out the transfer function for a signal flow graph. So we'll see for the same signal flow graph, same diagram. So how to construct, how to find out the transfer function. TF, what is the Mason's gain formula? TF is equals to 1 by delta sigma PK and delta K, where PK represents path gain of the kth forward path and delta represents determinant of the graph, and delta K is which is the value of delta for the product of the graph not touching the kth forward path. So first, for this problem, for this signal flow graph, so how many forward paths are there? Since P represents forward path, so first I have to find out how many forward paths are there.
Hello?
That is nothing but K. Forward path, what is the definition of forward path?
Hello?
Hello? Are you there?
Sir, I can't hear you, sir.
Okay. What is the definition of forward path?
The branches which are touching each other, but it's the node is only you only go through the node once.
Yeah, that is the path definition. Forward path. It is a path from input node to output node.
Output node.
So
Right.
here input node is X1 and output node is X5. So how many paths are there? So how many ways?
One path.
Check clearly.
Two paths are there.
Two paths are there. So what are the path gain? So P1, so K represents here, since here there are only two paths. So see the arrow directions also. So this is one path. I'll so K represents 2. Since here in this problem two paths are there, K represents 2. The formula becomes, transfer function becomes P1 delta 1 plus P2 delta 2 by delta. So here the unknowns are P1, P2 and delta 1, delta 2 and delta. So these are unknowns. Once I find out unknowns, I will get the transfer function. So K here 2, since there are two forward paths. So what are the forward path gain? P1 is forward path gain and P2 is the forward path of second forward path. So what is the forward path? First one. So X1, X2. So this is the forward path, right? This is one path.
Right.
From input node to output node. So gain is nothing but A12 into A23 into A34 A45. So this is the forward path gain. So next forward path? No, A44 is a loop. It is a path.
A35.
Come again?
A35.
Complete, no, A35, no. Complete path gain, you tell me.
A34. A35.
A34, where it is? A34, A45.
A3. Oh wait.
No, forward path.
A34, A35.
Forward path. Definition of forward path is it is a path from input node to output node. One forward path I given A12, A23, A34, A45 into 1. So A12, this is the path. See that I am trying. This is one path started at input node and reached at output node. Similarly, tell me in the same directions are given. If you observe clearly, this is also one path, forward path.
Yeah. Okay.
A12,
A23,
A23,
and then A35.
yeah, into 1.
Yeah, into 1.
A12, A23, and A35. So these are the forward path gain. So this is the path I am just trying. See. So here input node, the directions is given in the signal flow graph. So this is a path which started from input node to output node. Okay, here in this problem there are two forward paths are there. So if you next P1, P2 I got it. P1, P2 I got it. Next delta I have to find out. So delta is not is delta. If you see in the formula, delta is nothing but determinant of the signal flow graph. How to find out delta? 1 minus sum of loop gains of all individual loops plus sum of gain products of all possible combinations of two non-touching loops minus sum of gain products of all possible combinations of three non-touching loops, so on. So here individual loops, how many individual loops are there for this signal flow graph? A loop is a path which originates and terminates at the same node.
Individual one.
How many are there? Individual loops.
X2, X4.
So I am writing as individual loop as IL. So individual loops are 5 are there. So what are those? L1 loop gains. L1 is nothing but tell me that loop gains. So A23, A32. So here this loop is started and terminates at the same node, that is X2. So one loop gain is A23, A32. Yeah, one more loop. See, this is also one more loop. A23, A34 and A42. Here started at X2 node and ended at same node. See clearly from X2 I started, gain A23, A34 and A42. So loop gain L2. A23, A34, A42. So next one, 2 loops are over. Out of 5, 2 loops are over. Remaining 3 are there. So this is also one loop.
A23.
A44. Here
Okay.
started at X4 node and ended at same node. So this is also a loop, individual loop.
Right.
So A44. L3 is equals to gain is A44. Next, remaining two loops are there, L4, L5.
A34, A45.
A34, A45.
But A35 is in the same direction, but not a loop, right?
No, that is not a loop. See, A23, A35 and A52. Right? I started at X2. A23, A35, A52. This is also one loop. A23, A35, A52. Any doubt?
Okay.
A23, A35, A52. So the last one loop we have to tell. So the L5. See the signal flow graph clearly.
A23,
Hmm.
A45, A52.
A23. Next.
A34,
A34.
A45,
Yeah,
A52.
correct. A23. A34. A45. A52. So these are all individual loops, right? So in the formula, this part is over. Sum of loop gains of all individual loops. Out of all individual loops, two non-touching loops. That non-touching loop is nothing but two individual loops which are not touching at the same node. So here any two loops which are not touching at the same node, you tell me which are the individual loops out of 5 individual loops, which two loops are not touching at the same node? L1, L3. If you see L1 and L3, L1 is A23, A32. So the A23, A32 this is, and this is one loop. These two loops are not touching at the same node, right?
Correct.
So non-touching loops. I will write one more whiteboard. So non-touching loops, what is that? L1 and L3. Just I am writing as L1, L3. This is one combination. Any other combination? See, A23, A35,
Okay.
A52, this is one loop, and A44 is one loop. These two loops are also not touching at the same node, right?
So
A23,
yeah,
A35, A52.
A52.
So L4 and L3. L3, L4. Okay. Any combination for 3 non-touching loops, that means 3 individual loops which are not touching at the same node. 3 out of 5 individual loops, check whether any 3 individual loops which are not touching at the same node. Similar to the 2 non-touching loops, how you return, in the same way, 3 non-touching loops. Any combination is there?
No.
No, right? So if 3 non-touching loops is not there, so 4 non-touching loops are also not there. So in the formula, so 1 minus loop gains individual loops is over, 2 non-touching loops is over. So this part is not there, so this part 0 in our problem.
Okay.
So write delta. Delta is nothing but determinant of the signal flow graph. 1 minus, see the formula, 1 minus sum of loop gains of all individual loops. So here individual loops are L1, L2, L3, L4, L5. Sum, I have to write sum. So just I am writing as L1 plus L2. So in the actually we have to write L1, L2. Here I am writing just L1, L2,
L3, L4.
L4, L5. These are the sum of loop gains of all individual loops. Next, next plus sum of gain products of all possible combinations of 2 non-touching loops. I already gained product I done, that is L1, L3 and L3, L4. So here polarity is alternatively, so plus 1 minus again plus L1, L3 plus
L3,
L4. So this is the determinant of the graph. So out of the formula P1, P2 I've already calculated, delta I calculated. Remaining unknowns are delta 1 and delta 2. So delta 1 how to find out? So what is the definition? Delta K. Delta K is nothing but value of the delta, both are same. Delta and delta K both are same, but for the part of the graph not touching the kth forward path. Since I am writing delta 1, so 1 is represents first forward path. So for the first forward path, what is the first forward path? A12, A23, A34, A45. So this is the first forward path. So for this path, all the loops are touching this path, right?
Right.
But I have to take which is not touching the first forward path. I have to take the graph which is not touching the first forward path. But this path, all the loops touching the first forward path. So therefore delta 1 is 1. These are all 0. L1, L2, L3, L4, L5, all are 0 only. So similarly delta 2. Delta 2 is also a value of delta. I have to take which is not touching the second forward path. So what is the second forward path? A12, A23, A35. A12, A23, A35. This is the second forward path. So out of this path, any loop which is not touching the this second forward path, 5 individual loops we already written. So A44 which is not touching this forward path. So 1 minus. So A44 which one? A44 is L3. Remaining all is touching. So I have to take which is not touching the kth forward path, second forward path. So 1 minus L3. Then transfer function. Just substitute all these things in the formula transfer function. So 1 by delta. Delta I already calculated. P1, delta 1 is 1 plus P2, delta 2. Just substitute and write it overall.